Okay. So in the next half of the course, we'll be dealing with linear algebra, applications of linear algebra. Okay. So mainly applications of linear algebra. See, like there are few methods we are trying to understand here. One such is, there are two main problems. First problem is what I told you in the bridge course. That is solving Ax equals to lambda x. That is finding, or better word would be computing eigenvalues. Coming ahead, we are discussing. So finding eigenvalues. For that, you have this eigenvalue problem. Eigenvalue problem. For those who are not aware, A is a matrix, X is a vector, lambda is the eigenvalue, X is the eigenvector. Again, okay. So you compute eigenvalues, but computing eigenvalues for a 2 by 2 matrix is quite easy, because that will lead to a, for a 2 by 2 matrix, the computing eigenvalue is similar to solving a quadratic equation. Which all of you know how to solve. And that is not cumbersome, that is not difficult. But when you go on from 3 by 3 matrix, it starts getting difficult, because then you will have something like lambda 3 plus some equal to 0, a order 3 polynomial, which is very difficult to solve analytically. There you can use some other method, okay, like root finding method we have discussed. And 4 by 4 and all, if you consider larger matrices, it gets complicated. So there has to be and there cannot be analytical methods, because it is too complicated to solve using analytical methods. Okay, so how you will solve? So there is a particular method. Yes, you can use root finding, but yes, something better than root finding is found. So that is known as power method. So this is again an iterative method. Power method is again an iterative method. Maybe this. It is again an iterative method that we will learn in this course. What else we will be learning in this course? Another approach is equations of the form Ax equals to B. Equations of the form Ax equals to B. What is Ax equals to B? That will be covering next in next part of the course. This currently after this. If you have 6x plus 5y equals to 36 and 5x plus 8y equals to 43. Okay, I want to find the root of this, root to this simultaneous equation. These are simultaneous equations, isn't it? Because you have two equations, two linear equations, and they have x to the power 1 and y to the power 1 components, and these are two coupled like equations. So one way to solve this is graphical method. That means if you have both x and y, this equation 1 will represent a straight line, equation 2 will represent a straight line. Don't think I'm writing it here like that. Maybe this line, another is like, say, this line, and they intersected here. So this is the root. This is the xy plane. But the moment you start having more equations to this, like say you are doing like 6x plus 8y plus 5z equal to 32. X plus 8y plus 9z equals to 45, and 8x 9y 16z equals to 33. So this is a 3 by 3 system. Okay, so this is a 3 by 3 system. Now instead of curves, instead of straight line, you have to deal with planes. Okay, the planes, to these three planes, each of them represent a plane in the 3D surface. Okay, you can draw this 3D surface, and the plane, this is one plane P1, this intersects maybe in a line, or maybe it can intersect at a point also. So depending on the solution is complicated. Okay. So therefore, you see the complication starts to get increasing, right? It starts to get complex. Yes. So even if you have more unknowns, because in real world situation, you will have rain. Suppose rain is a parameter. Rain depends on precipitation, like rain depends on the temperature, rain depends on the humidity, rain depends on many factors. So you have to consider all these factors. So rain is a function of all these factors. So therefore, your variables keep on increasing. So you don't have a control in real world situations upon the number of variables. Okay. So in these kind of situations, how will progress? Okay. That is the situation here. So you know that the moment you cross the dimension 3, the moment you cross dimension 3, graphical approach fails, isn't it? What do you think? Can you visualize a 4-dimensional? No, not yet. So therefore, you can of course visualize it by taking slices. Okay, slices. But still, if more dimension is dimension 4 problems you are trying to solve, then graphical method is not prevalent. Okay. In that case, you have to use some other methods. Okay. Some methods are like Gauss elimination. Gauss elimination method that we will learn. That is not an iterative method. Not an iterative method. It just follows the calculation. That's it. Okay. Another is Gauss-Jordan. Gauss-Jordan method. Okay. Right. So these are some of the methods we will be learning next. Okay. Yes. And then you will be learning about some decomposition of matrices. That is the third part. So this is the third part of the course. So this is the second part which is coming ahead in our course. This is the third part. After this, after we complete Gauss elimination, Gauss-Jordan, we will come into third part. That is how to decompose matrices. But first of all, why we will decompose matrices? A matrix A, okay, a matrix A, okay, if it can be decomposed into say QR, that is a QR factorization method. And similarly, in my bridge course, I told you about SVD. Okay, so these are like decomposing matrices. These are known as decomposing matrices. Okay, so how decomposing matrices can help you in your simulations, can help you in your computations. Sometimes matrix A is difficult to analyze. Therefore, if you do split into Q and R, then it gets easier. Then it gets easy. Okay, that's the idea. So therefore, you will come to know two methods. Okay, the one method is LU decomposition, where you can decompose your matrix A into a lower triangular matrix multiplied with an upper triangular matrix. And we will see what advantage is there if you decompose matrix A into L into U. Okay. There is also some other method like Doolittle, but I'm not sure if we will cover it. Doolittle method that is there, and yes, one more thing, one most important in the course is must have saved here. Yes, this one. Okay, so I think many of you watched this T20. Many of you watched this T20 match of Sri Lanka versus India. Okay, or the ODI matches, where I think India did not win. But anyway, so why I'm talking about this here? We'll be discussing interpolation. Okay, what is interpolation here? In cricket matches, they have started using DRS. So you can see when the ball hits the player, like the Sri Lankan player in blue, in this here he is batting. So this is the point where the data is there. Okay, in graphic system, in video recording, this point here, which is covered already, is known to the audience. Okay, then this point is known to the audience. Okay, then predict where it can go, if it can hit the wicket. Okay, but it did not hit the wicket because it hit the player. Okay, they want to know by extrapolation, by extending. So how many points you know here? there are 4 points in the picture. Can you identify those 4 points? So if you see, there are 4 points in the picture. One is this one, one is this one, and another is fourth is this. Okay. So one, second, and third, you already know. The data you already have. Based on these data, 1, 2, and 3, you want to predict where this point will go ahead. But mind you, it is not generating. Did it say where the ball will go here? No. It does only the point where it is required. And since the player will always be near the wicket, so the distance is very small, so they can predict with better accuracy. The moment they increase, they are trying to predict where the ball goes later, the accuracy decreases. Okay, so you can see now they are predicting it here. Okay, without even the ball hitting in real scenario. So this is not interpolation, my bad. This is extrapolation. Given these 3 data points, you are extrapolating your data. Okay, so this is an example of extrapolation which you can see is used in cricket. Example. Okay, so that will be our final version of the course, where we will be discussing about fourth. Oh no. Yes. So the fourth part of the course, that is interpolation. Okay, interpolation and extrapolation. That will be our fourth part of the course, and there we will wrap up the course. Okay. So I am telling you what are we going to learn in this course. Fine. Everyone the same page now. Okay. Anyway, so this is what I thought. What do you think? Shall we discuss more or next class? Next class. So maybe we can start fresh next class. Make sure that I'm giving 30 minutes already. Okay, 30 minutes. So make sure next class no one should sleep or no one should be like drowsy or anything. Okay. Next class, make your mind fresh. Next class will be something you need patience because you will be dealing with matrices. You need patience. Okay. Yeah, done.